Hello everyone. In this video, we shall discuss the values of the six trigonometric functions of the angle theta, in which the terminal point of theta is anywhere on the Cartesian plane. So this means that the terminal point of theta may or may not be on the unit circle x squared plus y squared equals 1. Now, to start off, let us discuss what are the signs of the six trigonometric functions across the four quadrants. So if you recall, the terminal point of theta is x comma y. So we have p of theta equals x comma y. And in quadrant 1, the value of x and the value of y are both positive. So x is positive and y is positive. In quadrant 2, the value of x is negative and the value of y is positive. In quadrant 3, the value of x is negative, the value of y is negative. And in quadrant number 4, the value of x is positive and the value of y is negative. And recall that on the unit circle, x squared plus y squared equals 1, the sine theta is defined to be the y coordinate, cosine theta is the x coordinate, tangent theta is y coordinate over x coordinate, cotangent is x over y, secant is 1 over x, and cosecant is 1 over y. So if we want to determine the signs of the six trigonometric functions across the quadrants, we will just use the following information and the formulas of the six trigonometric function. So since in quadrant 1, both x and y are positive, then that means all of these values are also positive. So that's why in the first quadrant, all the six trigonometric functions have positive signs. Now in quadrant number 2, x is negative and y is positive. So that means sine of theta, where theta is in quadrant 2, that will be positive because the y coordinate is positive. Cosine theta, which is x, would be negative because x coordinate is negative. And then for tangent theta, since the formula is y over x, that will be positive over negative, which is negative. And then for cotangent theta, that will be negative over positive, which is negative. And then for secant theta, that's going to be 1 over negative. So that's positive over negative is negative. For cosecant theta, that's positive 1 over the y coordinate, which is positive. So that means the cosecant is also positive, is positive in quadrant number 2. So using that information, we can also derive the signs of the six trig functions for quadrants 3 and 4. So for quadrant 3, both x and y are negative. So the only time that the trig functions will be positive is when we're using the tangent and cotangent theta. So since the formulas are y over x and x over y, that will be negative over negative, which is positive. And the following will be also negative over negative, which is positive. And then the rest will be negative. And then for quadrant number 4, um, only cosine and secant are positive because the x coordinate is positive. So that means cosine is positive, secant is 1 over positive, or positive over positive is positive. So to summarize this on the Cartesian plane, in quadrant 1, all are positive. And in quadrant number 2, only sine and cosecant are positive. In quadrant number 3, only tangent and cotangent are positive. And in quadrant number 4, cosine and secant are positive. So we're going to use this information later on in finding the values of the six trigonometric functions at any terminal point. All right, so let's have an example for determining the correct quadrant given certain information. So for this slide, it says determine in which quadrant does the terminal point P of theta would lie given the following. So the first example is when sine theta is less than 0 and secant theta is greater than 0. So sine theta less than 0 means that sine is negative, and secant theta greater than 0 means that secant is positive. So sine theta is negative in the quadrants 3 and 4. So we're going to have P of theta could be an element of quadrant 3 and quadrant 4 or quadrant 4. And then secant theta is positive whenever the angle is or the terminal point is in quadrants 1 or 4. So that means P of theta here is an element of quadrant 1 or quadrant number 4. So using this information, we can conclude that P of theta must be in quadrant number 4 because that's the quadrant that is common to both these information. Okay, for our second example, tangent theta is greater than 0, that means tangent is positive. Cosine theta is less than 0, that means cosine is negative. So tangent theta is positive in quadrants 1 and 3. So this means that the terminal point of theta will be in quadrants 1 or 3. And then cosine theta is negative in quadrants 2 and 3. So this means that P of theta is in quadrant 2 or quadrant number 3. So the common quadrant would be quadrant number 3. So this means that the terminal point of theta is in quadrant number 3. Now this information would help us about the sign of the x-coordinate and the y-coordinate of the terminal point. So if the terminal point is in quadrant number 4, that means x is positive and y is negative. So this is actually important later in finding the values of the six trigonometric functions. Now, if the terminal point of theta is in quadrant number 3, that would mean that x comma y would be negative comma negative. So if we have an angle theta in standard position with terminal point P of theta equals x comma y that lies on the circle x squared plus y squared equals r squared, then the six trigonometric functions are defined as follows. So sine theta is y over r, cosine theta is x over r, tangent theta is y over x, cotangent theta is x over y, secant theta is r over x, cosecant theta is r over y. So this is just similar to the formulas that we had during our discussion of the six trigonometric functions using the unit circle. So in the unit circle, if we have x squared plus y squared equals 1, this means that we can write this as x squared plus y squared equals 1 squared. So this would imply that r is equal to 1. So which means that if we're using the unit circle, these values would be equal to 1. So which is consistent with the formulas for the six trigonometric functions using the unit circle. So we shall use this information in order to answer the following problem. So let's have an example. Determine the values of the other five trigonometric functions given the following information. So we have sine theta is 3 over 7 and cotangent theta is less than 0. So since sine already has a value, we need to find the value of cosine theta, tangent theta, cotangent theta, secant theta, and cosecant theta. So the first step here is to find the location of the terminal point of theta. Okay, so since sine theta is equal to 3 over 7 and this is positive, that means the terminal point of theta may be in quadrants 1 or 2 because sine theta is positive in quadrants 1 or 2. And then cotangent theta is less than 0, that means it's negative. So that means the terminal point of theta could be in quadrant 2 or in quadrant 4. So that means this terminal point must be in quadrant number 2 because that's the common quadrant. Okay, so this means that x comma y, x will be negative and y would be positive. Now, from our definition of sine theta is y over r. So since y is always positive, then y must be equal to positive 3 and r is positive 7. Actually, r is always positive in this case. Okay, so to get the values of the other trig functions, we need to solve for the value of x. So the value of x will come from the Pythagorean relationship x squared plus y squared equals r squared. So this means that we have x squared plus 3 squared, that's y squared equals r squared is 7 squared. So this means that x squared is equal to 49 minus 9, which is 40. And solving for x by the square root property, this will be positive negative square root of 40, or in simple terms or simplest form, positive negative square root of 40 will be positive negative 2 square root of 10. Okay, because 40 is 4 times 10 and square root of 4 is 2. That's why 2 is outside of the radical. Now, if x is positive negative, what would be the correct sign that we should adapt for the x coordinate? So since the terminal point of theta is in quadrant number 2, that means x must be negative. So this means that we're going to take only the negative value of x. So to get the other values of the other 5 trig function, cosine theta is x over r. So that's going to be negative 2 square root of 10 over 7. And we have tangent theta is y over x, which is 3 over negative 2 times square root of 10. So if we rationalize this will be equal to 3 square root of 10 over 20. And that should be negative. It's because of this negative sign here. And then cotangent theta is x over y. So that's going to be negative 2 square root of 10 over 3. And then we have secant of theta. Let's write it down here. Secant of theta is r over x. So that's going to be 7 over negative 2 square root of 10, which is equal to 7 square root of 10 over 20. And it's negative because of this negative sign here. And then cosecant of theta is r over y, which is just the reciprocal of sine theta, which is 7 over 3. So observe, so since the terminal point of theta is in quadrant number 2, only sine and cosecant are positive, and then the rest are negative. So cosine here is negative, tangent is also negative, cotangent is also negative, and secant is also negative. Now let's have another example. So this time, let's find the values of the other 5 trig functions, given the information that secant of theta is negative 5 and cosecant theta is less than 0. So this means that secant is negative. Cosecant theta is less than 0. That's also negative. So secant is negative in quadrants 2 and 3. Cosecant is negative in quadrants 3 or 4. So that means that the terminal point of theta is in quadrant number 3. So which means that the terminal point or the coordinates of the terminal point are both negative. So now secant theta is equal to r over x. But we know that r is always positive. So if secant theta is equal to negative 5, then r here must be 5 and x must be negative 1. So because 5 over negative 1 is negative 5. So to solve for y, we are going to use the Pythagorean theorem. So x squared plus y squared equals r squared. So that's going to be negative 1 squared plus y squared is equal to 5 squared. So this is going to be y squared is equal to 25 and then minus 1, which is 24. So y will be positive negative square root of 24. And we know that square root of 24 can be simplified into 2 square root of 6. Because 24 is 4 times 6, and square root of 4 is 2. So that's why there's a 2 outside of the radical. Okay, so here the other 5 values will be sine theta is y over r. However, since the terminal point of theta is in quadrant number 3, that means the y coordinate should be negative. So we need to take y to be negative 2 square root of 6. So sine theta will be negative 2 square root of 6 over r, which is 5. Cosine theta is x over r. So that's negative 1 over 5. That's the reciprocal of secant. Tangent of theta is y over x, which means that we have negative 2 square root of 6 over x, which is negative 1. So that will be positive 2 square root of 6. And then cotangent theta is x over y. So that's going to be negative 1 over negative 2 square root of 6. So we can rationalize this by multiplying both numerator and denominator by square root of 6. So multiplying it by square root of 6, we get square root of 6 over 12. Okay, so this becomes positive because both numerator and denominators are negative, so the quotient will be positive. And then cosecant theta is r over y. So r is 5, and the value of y is negative 2 square root of 6. So again, if we rationalize this gives us negative 5 square root of 6 over, yeah. So observe that both tangent and cotangent are positive because those are the only trigonometric functions that are positive in quadrant number 3, and then the rest are negative. Okay, so this ends our video about finding the values of the six trigonometric functions at any real number or at any terminal point. So I hope that you learned something in this video, and I do hope that you will subscribe into my channel. Thank you for listening.